Welcome to this third session on operational amplifiers. In this third session, we are not going to study something new, but we will try to solve various examples by considering much complicated circuits in the sense that you should get enough confidence of working on any example. It would be just like only one condition, that there has to be some connection between output and inverting terminal. Based on that, everything is, many combinations are possible. In fact, you can also perform various examples. Then after this lecture, we will be loading the assignments in Google Classroom, which you are supposed to solve and report back in the Google Classroom. So it is op-amp circuit examples. Various different kinds of circuits we will go for. The logic is same. We have to, thumb rules have been already given, and based on that you are supposed to proceed. Calculate potential at inverting, and then calculate potential non-inverting, transfer to inverting, that is all. So when I say example, it is numericals. The all resistances we take would be in kilo ohms, all in kilo ohms, so that as all in kilo ohms, since it is ratio, while calculating currents, we can take it to be as good as ohms, because it is going to cancel everywhere. So currents would be in milliamperes in that case, and they would be equal. So each time there is no need to write upon 1000, upon 5000, you can write upon 1, upon 5. Only thing is that current will be, the unit for current, unit for voltage is volts, unit for resistance what we are taking is kilo ohms, which will give rise to unit for current in milliamperes. So that will reduce the calculation burden. And each time the question is, the question remains same, calculate VO and VB. Actually, calculation of VB is not required as it is VA, but if output goes beyond saturation, then you have to, suppose if output comes to minus 18, you should say output is minus 15, and again calculate VB, because based on VB equal to VA you have calculated the output, which cannot remain, so it has become wrong, so you need to recalculate. So VA is here, VB is here. So now step 1 is assumed, step 2, calculate potential at non-inverting terminal. No need to calculate. Why? Because since op-amp draws no current, 2 volts are here, no current flows through this resistor. 2 volts are here, no current flows through the resistor, so drop across this resistor will be 0. So this what is this voltage? This voltage minus this drop. Since current is 0, drop is 0, so this voltage equal to this voltage, so VA is equal to 2 volts. So VA is 2 volts, so VB is 2 volts. VA is 2 volts, VB is 2 volts. Now calculate VO, apply Kirchhoff's law at inverting terminal. So this is one current I1, this is another current I2, this is another current I3 or IF you can say, and just write IF is equal to I1 plus I2. Directions you can assume anything, there is no problem. You should select direction from more to less like that, no need. Any direction you can assume and the circuit, the Kirchhoff's law will give you correct answer. So, because of Kirchhoff's laws, current incoming, you have assumed the direction equal to current outgoing. So, IF is equal to I1 plus I2. What is IF? IF is VB minus VO upon 2. I will not use kilo ohm now. So, VB, that is 2 minus VO upon 2 is equal to 3 minus 2 upon 3 plus 1 minus 2 upon 1. 1 minus 2 upon 1. So, I rewrite again, 2 minus VO upon 2 is equal to 1 upon 3 minus 1, 1 minus 1, right. So, I think it is high school level problem, multiplying everything by 6. So, 2 is here, 3 is here, better way to get rid of denominator. So, this multiplying everything by 6, it becomes, so 2 is here, so multiplying by 6 is multiplying by 3. So, 6 minus 3 VO is equal to, this is denominator is 3, so multiplying by 6 is 2 minus 6. So, 2 minus 6 is minus 4. So, minus 3 VO as it is equal to 2 minus 6, I write again, 2 minus 6, this minus 6. So, minus 3 VO is equal to 2 minus 12, that is minus 10. So, VO is equal to plus 10 by 3 volts. One suggestion just for exam purpose, when you calculate VO, you keep it a practice to write plus by giving plus sign, even though no sign means plus, but so that there should not be any ambiguity, you keep it a practice that when you write the final answer, write as plus. Only 10 by 3 is also correct, but you write plus specifically so that nothing is wrong, right. So, this is an example where calculated VO is within the window and that is all, everything is right. So, what is VB? VO is 10 by 3 and what is VB? VB is equal to VA, what you have calculated, VB is 2 volts. So, answer is VB is 2 volt and VO is 10 by 3. It is the correct answer, final answer, that is all. I hope it is quite simple. We go for next example. Since it is recorded, nobody can complain that no, we wanted to take down, we could not. You can just stop the video and take it down if ever you really wish to. There is absolutely no limit to complicate the problems. We purposefully complicate so that you get a good hand, you get a good practice. Once it is just like circuits and network problem using Kirchhoff's and Ohm's laws. So, now there are two ways, go from simple, but if you discuss one difficult problem, everything is covered there. So, here again same thing, VA, VB. No need to get panic at all, only thing is that you have to cover two nodes, that is this node as usual and this one more node has come, but absolutely there is no need to worry. So, first of all, This also I made deliberately complicated, so nothing should be left. So first of all, calculate VA. You don't skip any step. Calculate VA. What is it is? 4 volt, 1K, 1K. So it is 2 volts. So VA is equal to 2 volts. There is no need to have separate calculation. So VA is 2 volts. So the idea is very clear. VB is 2 volts. VB is 2 volts. Now we have logically disconnected. Now the current directions are to be assumed. How do we assume them? Then this is I1. This is I1. Now here you can't write directly in terms of VO because this has come in between, but let us not worry about. Let us go step by step. It is still, I persist, that a high school level problem, not high school level we can say high school scholarship level problem, so somewhat advanced. Then now we give this as this I1, so this I1. So I don't write again IF because no point in applying Kirchhoff's law here because this is 0. So this I1 same is this I1, same is this I1. Then this I call as IF, and this would be I1 minus IF, I1 minus IF. So now op-amp is not there, we are just solving a general high school level algebra numerical. So we just write, what is I1? I1 is equal to 3 minus 2 upon 1. That is I1 is 3 minus 2 upon 1. So I1 is equal to 1, everything in milliamperes. I1 equal to 1. Now this voltage is there, one more node. This I will call as VC. I call it VC. Now you can very easily calculate VC. There is no need at all. How will you calculate VC? Since no current flows here, same I1, that is 1 milliampere, must flow from VB to VC. So what is I1? Which is 1, VB minus VC upon 1 is equal to 1. Why? Because I1 is 1. I calculate I1 first, same I1 should flow through this. So what is VB? VB is 2 minus VC upon 1 equal to 1. So what is VC? So that gives rise to 2 minus VC equal to 1. So VC equal to 1 volt and plus 1 volt. VC equal to plus 1 volt, and then the Kirchhoff's law will give us very simple thing, that is, what is this? This I1 minus or what I do, I don't take this current, I don't assume at all, I just leave it as it is. Now VC I have found out, then at this node I assume this current direction, I will call this as I2. What is I2? What is VC? VC is 1 volt, this resistance is 1K. So what is I2? I2 is equal to VC, which is VC minus 0 upon 1, but VC is 1, so 1 minus 0 upon 1, so I2 equal to 1 milliampere, I1 equal to 1 milliampere, I1 equal to 1 milliampere. So this 1 milliampere, this 1 milliampere, so this is 0 current. So if this is 0 current, VO should be equal to VC, but this is something which you don't accept by mind, so I just change the value. I will make this as 2K, so that things become simpler. So if it is 2K, I2 is upon 2, this is upon 2, so I2 is 1 by 2 milliamperes. I1 is 1 milliampere we have calculated. So again very simple, this I1 is 1 milliampere, this I2 is 1 by 2 milliampere. Now there is no need of any kind of a super expert to tell me what would be this current. This I can now call as IF. This I can call as IF. So this I1, I2 I have deliberately chosen direction. I could have chosen this also, there is no problem. Just I have chosen suitable direction. So current incoming is 1 milliampere. So applying Kirchhoff's law at VC node, I1 is current incoming, that must be equal to current outgoing, I2 plus IF. So what is I1? I1 is 1, I2 is half plus IF. So that gives me IF is equal to half milliampere. Oh, not IF, I made a mistake, I subscript F. IF is equal to half milliampere. If IF is half milliampere, in that case, how will you calculate VO? You know VC, VC is 1 volt. Apply Ohm's law for this resistor. Apply Ohm's law for this resistor. So what is Ohm's law for this resistor? VC minus VO upon 2 is equal to IF. But you know IF is half. This is 2 in kilo ohms, half in milliampere. So you can say VC minus VO upon 2. This milliampere you assume, but don't again multiply by 0.001 is equal to half. VC minus VO is equal to half. So 2 in the denominator gets cancelled. So VC minus VO is equal to 1. VC is 1. VC is 1. 1 minus VO equal to 1. VO equal to 0 is the answer. VO equal to 0 is the answer. As I repeat, this is the most complex example of having a T section in feedback. I have taken this example so that the other examples which few might have found it difficult, they can again replay and see. Somehow VO has become 0 volts. So if you, anyway, it doesn't matter. We have calculated everything based on simple logic. Once you calculate VA and take it here, op-amp role is finished. Otherwise, it is simple Kirchhoff's and Ohm's laws. And once you put them, it is high school level algebra. That's all. So this is enough. So we proceed for, I think, most complicated example we have taken. Now we can very easily go for the simpler examples. We can have T here, there is no harm. This we ground, this we keep as 2 volts. We make symmetric 1K, 1K, 1K. VO. Now how will you proceed? Again, apply simple common logic. This is 0 volts, no need to calculate. So write just this as VA. This is VB. So this is 0, so this is 0. Disconnect already. Then how do we proceed? Assume this to be I1. Assume this to be I1. Assume this to be I2. So this is I1 minus I2, and this is I2 because same current should flow. So there would be one voltage which will come here as VC. So how do we calculate? Go step by step. First, I1 2 minus Vc upon 1. I1 is equal to 2 minus Vc upon 1. Now what do we do? Instead of assuming this, it is better to assume this as I2. This as I2, and then this would be I1 minus I2 and I1 minus I2. What is I2? I1 is 2 minus Vc by 1, means I1 is equal to 2 minus Vc. What is I2? Vc we rewrite Vc minus 0 upon 1. So I2 is Vc. I2 is Vc. I1 is, I think there is no need of any kind of confusion because of this T. 2 minus Vc upon 1 is I1. Vc upon 1 is I2. I1, this current is I1 minus I2. So what is I1 minus I2? I1 is 2 minus Vc. I1 minus I2 is equal to 2 minus Vc minus Vc again. So I1 minus I2 is equal to 2 minus 2 Vc. I1 minus I2 is equal to 2 minus 2 Vc. But there is a problem. The problem is Vc we don't want. Vc we don't want. So how we calculate Vc? Vc we can calculate. Can we calculate Vc by other method, or we can so I1 minus I2 is also equal to I1 minus I2 is also equal to Vc minus 0 upon 1 because of this branch Vc. This voltage I know. If I was not knowing this voltage, then problem would have occurred. Vc minus 0 upon this current is equal to, Vc minus 0 upon this resistor is equal to this current. So I1 minus I2 is equal to Vc. I1 minus I2 is equal to Vc. So what has happened? I1 minus I2 is equal to Vc. So what you do? We want to get rid of Vc. So use this equation in reverse form. Vc is equal to I1 minus I2. This is equation 1. This is equation 2. Putting 2 in 1, what you get? I1 minus I2 is equal to 2 minus 2 into bracket I1 minus I2. So this is actually, you can write this, or you can write this as If also. So this comes on this side. So 3 into bracket I1 minus I2 is equal to 2. So I1 minus I2 is equal to 2 by 3. And that same current should flow through this. So If is equal to 2 by 3. So once you know If equal to 2 by 3, you can simply solve the example by applying Ohm's law. 0 minus Vo upon 2 is equal to 2 by 3. So minus Vo is equal to 4 by 3. That means Vo is equal to minus 4 by 3 volts. I hope all figures are legible. So this is next example. Now we will take some examples with saturation, because in all these examples output is coming in between plus minus 15. So, the question is, what is the question? Calculate VB and VO. So, initially you calculate VB just by transferring VA there, then calculate VO. Since output is between plus minus 15, everything is right, our purpose is served. Now, we take example where it is, what we can say, changed. I apply direct 2 volts here, I can apply no problem. Now, calculate VB and VO in this case, two cases. If V1 is equal to 3 volts and V1 is equal to 8 volts. There are 2 examples. So, we start. There is no point of first and second thumb rules. VA is given directly. Just disconnecting from mind. VA is 2 volts. So, VB is 2 volts. So, this V1 in the first example is 3 volts. So, this current is equal to this current. So, I think now there is no need, we get I1 and this is IF. What is I1? I1 is we write IF equal to I1. So, what is IF? IF is 2 minus VO upon phi u is equal to I1 is 3 minus 2 upon 1. So, it is 1, if phi goes on the other side, 2 minus VO is equal to 10, which gives rise to 2 goes on this side, minus VO is 8. So, VO becomes minus 8 volts. So, as VO is minus 8 volts, this is correct and this is also correct in the first case. Now, we go for second case. This in case of second, now we need to change some values. So, this becomes 8 volts, this 2 you take it to 2, IF is equal to I1, IF is 2 minus V upon phi is correct. One thing is that this becomes 8, 8 minus 2 upon 1. So, that is 6. So, 6 into 5, that is 30, 2 minus V is 30 and VO comes as minus 28 volts, and this now can't exist. So, minus 28 can't exist. So, which becomes VO equal to minus 15 volts. And as now calculated VO has not come correct, this assumption is wrong. We have to recalculate VB. How we recalculate VB? Again same thing, only thing is now VB is unknown. V1, that is now 8, 8 minus VB upon 1 is equal to VB minus VO, that is minus 15 upon 5. Minus 15 upon 5. So, 5 comes on this side, 40 minus 5 VB is equal to VB plus 15. So, 5 VB comes on this side, 5 VB comes on this side, 15 comes on this side. This gives rise to 25 is equal to 6 VB. So VB is not 2 volts but 25 by 6. So VO is minus 15, VB is. So by assumption VB was taken to be 2, VO was coming to minus 28, which can't come. So VO is made minus 15 and then calculate VB to be 25 by 6. So assume VB, calculate VO. If VO is in the window, everything is correct, no need to proceed. If VO goes beyond window, then seal VO to window and our assumption of VB equal to VO is wrong, recalculate VB. So I think various examples which we have considered, this is enough for you at this stage. Students can work on their own for the various examples. In the next lecture, small session or in the remaining part of this session only, we will give the idea of ideal op-amp characteristics. This will complete the module of op-amp and then we can go for last module 555, which will take around 3 sessions of 45 minutes, around 2 hours, and then we will go for transistor and then we will go for the sequential circuits. I think with that we presume to close everything. Thank you.